Hello friends, welcome to pericyclic reactions part 3. In this we will learn the conrotatory and the disrotatory moments. In the previous video we have learned about these two molecular orbitals. In 1,3-butadiene case there is 4 electrons that we have to show, and in 1,3,5 hexatriene we have 6 electrons to show. So these type of system, they are called as 4 pi electrons, and this it is called as 4n plus 2 pi electron systems. Okay, so these are the two systems that we have to check. Another condition that we have to remember is there are two things, that is thermal reaction, very important, the thermal reaction, and the photochemical reaction. Both these conditions will give us different products. So we have to remember what happens in thermal and what happens in photochemical conditions. And the most important factor that we are looking for is only of the HOMO, the highest occupied molecular orbital of these two molecules, the molecular orbitals. Now in 1,3-butadiene, if you go for the thermal condition, we check only for the HOMO in the ground state. Okay, so if you remember, we have only 4 electrons here, 1 and 2 electron goes here. It follows Pauli's exclusion principle, Hund's rule of multiplicity, Hubble principle, etc., etc. So 2 electron goes here, the next 2 electron it goes here. So 4 electrons are done. So in this case, this is the HOMO. Okay, so in thermal condition, that is which is the ground state, this is the HOMO. Now what happens in photochemical state, which is excited state? In excited state, 2 electrons will remain here. Among these 2 electrons, 1 electron stays in this level, and then the second electron, it jumps to the next orbital. Okay, in excited state, one of the electron jumps to the next level, and this is the new HOMO for the photochemical or the excited state. So when you are considering thermal case, just consider only this orbital. When you are considering photochemical state, just consider this orbital. In 1,3,5 hexatriene, we have 6 electrons to show. So 2 electron goes here, next 2 electron here, and next 2 electron here. This is for the thermal condition, which is ground state. So in ground state, this is the HOMO that we are looking for. Okay, this is the HOMO. And in the photochemical state, which is the excited state, 2 electron here, no problem. Then comes the next 2 electron, and in these 2 electron, 1 electron stays here, and the second electron, it jumps to the next orbital. And now in photochemical state, this is the new HOMO, and we are only concerned about the HOMO of these two particular species for the conrotatory and the disrotatory motions. Now in the 1,3-butadiene state, I'll write here 1,3-butadiene state. It consists of 4 electrons, so it is a 4 pi electron system. Okay, and now the next thing, in thermal condition, and here it will be photochemical condition. In thermal condition, the HOMO was is this part, 2 lobes on the 2 phases here, and the 2 phases on the opposite side. So in case of thermal, the HOMO is here, like this. And in case of photochemical, the Homo was this part, okay, the two phases here up, these two phases here down. So we have two phases down and two phases up. When we are considering the conrotatory or disrotatory motion, we are concerned only about the last lobes. We have to check only at the last lobe. Now the first lobe here, it looks like this, one phase up, and the last lobe, the phase is down. Okay, one phase up and one phase down. We are concerned only about the final lobes, not concerned about these lobes. Okay, now in conrotatory, what is conrotatory? In conrotatory, the motions are the same. Now there are two motions. One, this motion, it is called as clockwise. It is clockwise, and the next one, this is called as anti-clockwise. Suppose both of these lobes, they follow clockwise direction. If they follow clockwise direction, they will be called as conrotatory. If one of the lobe follows clockwise and the other lobe follows anti-clockwise, they will be called as disrotatory. Motion. Rotatory. Now when they follow clockwise, both of the lobes, they will be conrotatory, and if one of the lobe follows clockwise, the next lobe follows anti-clockwise, they will be called as disrotatory. Let us understand the conrotatory motion and the disrotatory motion with the help of these two pens. Suppose if we are drawing the lobes of the 1,3-butadiene, here it is top, two down, and here. Just taking one example. Now here this lobe is up and this lobe is up. We are concerned only about the final lobes. We are ignoring this lobes. Okay. So in this phase is up, this phase is up. Now, so this is the example. This phase is up, this phase is up. Now suppose if I move this in clockwise direction, okay, this moves in clockwise direction, and if I move this also in clockwise direction, so what happens? This red part and this red part, they are on the opposite side. They are not meeting each other, so this will not lead to formation of any bond. Now suppose this also, it moves in anti-clockwise direction. Okay, this movement is called anti-clockwise, and the red part meets. Now they will form a bond, and once they are forming a bond, the reaction is complete. So this part is moving clockwise and this is moving anti-clockwise. So this is the disrotatory motion, because this one was moving clockwise and this one was moving anti-clockwise. So once their direction is opposite, they are disrotatory. Now suppose what will happen if one phase is up and the next phase is down. Okay, suppose I move it in the clockwise direction. I move this in the clockwise direction. This movement is called as clockwise. Okay, if I move it in the clockwise direction, again the phases are coming together, constructing overlap, and they will form a bond. So this, when both are clockwise, when both are moving in the clockwise direction, they are called as conrotatory. Okay, I hope you understand. Both the phases, one phase moving clockwise, another moving anti-clockwise, disrotatory motion. If the phases are different, both are moving in the clockwise direction, the phases come together, it is called as conrotatory motion.